And a square matrix is a matrix that has the same number of rows as columns. And the reason why we need to know what a square matrix is because we're going to need to use square matrices when we're doing our row operations. So 2 by 2, or 3 by 3, or a 4 by 4, or a 5 by 5. Those would all be considered square matrices. Okay. Now the second type of matrix vocabulary that I want you to write down is what is called an augmented matrix. And an augmented matrix has a vertical bar that separates the columns of the matrix into two groups. Okay. So for example, I'm just going to make up a system here. I don't know if it's a nice solvable one, but we're not going to solve it. So if we had the system, let's say 3x minus 2y equals 8, and x plus 5y equals negative 10. Just making up some numbers. I could turn this system into an augmented matrix. Okay, and to do that, I would create a square matrix out of the coefficients of my variables, and then I would turn it into an augmented matrix by putting my vertical line where the equal sign is, and my constants would be on the right of it. So this is what it would look like as an augmented matrix. So my coefficients are 3, negative 2 for my x and my y. Directly below that, I'm going to put my coefficients for the x and the y in the second equation, which would be 1 and 5. My equal sign will get a bar, and then my constants will go on the right, so 8 and negative 10. And then put my matrices bracket around. So now I have a square matrix on the left, a 2 by 2, and it's an augmented matrix because I have the vertical line in there. It's separating my column off to the right. Okay, so for your homework, I think the first few problems, given a system, write it as an augmented matrix. And I think the next 4 are, given the augmented matrix, write it as a system. Okay, so you should be able to go back and forth very easily between those two things. Okay? You got that down? Would you be able to do that? Given the system, write it as an augmented matrix? If I gave you a 3 variable, let's just make up another one here. If I had the system x plus 5y minus 4z equals 6, 2x minus 4y plus z equals negative 8, 2x plus 5z equals 1.
What would we do if like the y was attached?
Well, what would the coefficient be?
We had to move the y over? Or
Nope, what would the coefficient be if the y is not there? What number would make it go away?
I was just wondering if we have to move it all the variables have to be on the same side.
Oh, yeah. Yes, if that were the case,
So
yes.
like if it's 2x plus 5z equals y, we would have to move
Yes,
the y.
yeah.
Okay.
Right.
That's what I was asking.
Okay, I thought you meant if there is no y, what does that? I was thinking something other than what you were thinking. All right, so what would my augmented matrix look like? What would be row 1's numbers? 1, 5, negative 4, bar 6. Row 2 would be 2, negative 4, 1, and after the bar would be negative 8. Row 3 would be 2, there is no y, so 0, 5, and then 1. Okay? Scott?
We just leave our answers like that.
Well, no, now we're going to have to do row operations with that. If it just says convert it to an augmented matrix, then you would be done.
Right.
If it says solve using row operations, which is what we're getting to right next, you have to actually do the solving of it. Okay? All right, so now please write the following steps for matrix row operations. So these are the rules. When you're asked to do row operations to solve, you can only do specific things to your matrix itself. So, rule number 1. Any 2 rows of the matrix can be interchanged. Meaning, I can move row 1 down below row 2 and move row 2 back up to the top. Or if there are 3 rows, I could put row 3 up to the top and then shift them down. So I can move rows and interchange them within themselves. Okay? Number 2. The elements of any row may be multiplied by any non-zero real number. So the elements of any row may be multiplied by any non-zero real number. Just like you did with your scalar multiplication in section 4.4. Like when there was just a 5 in front of it, you would multiply everything by 5. So now what we're thinking is I can take any row and multiply it by a number instead of the whole entire matrix. All right, number 3. It's a big one. Any row may be changed by adding to the elements of the row that doesn't make sense. Of the row, the product. I feel like those are bad words there. And you're of the row, of the row, the product of a real number and the corresponding elements of another row. So any row may be changed by adding to the elements of the row the product of a real number and the corresponding elements of another row. I was doing a poor job of pausing in my sentence there. Yeah.
Can I have an example of what that means?
Yeah, you'll see what it's better when we just do it in practice.
I was going to say this.
So if I were to, let's say I multiplied everything in row 2 by 2, then I could add that new row 2 with row 3 and turn that row 3 into something new. This is pretty much what we'll be doing the whole entire time with our row operations. So after we do it, I think you'll get the hang of it. Okay? All right, so before we actually do row operations, we've got to talk about what our goal is when solving a system using a matrix. So our goal is to get something that looks like this. This is called row echelon form. So if you ever hear the words row echelon form, you have ones on your diagonals, and you end up with a 0 in your lower left-hand corner, and something else over here. Me personally, I always take it to all zeros, but your book for section 4.3 kind of lets you cheat a little bit and not go all the way through. Because if you think about it, remember the first column are your coefficients in front of, let's say, the x, if this is a 2 by 2. And then your second column would be the coefficients in front of your y. And then the numbers after your vertical line are your constants. So if I have 0x and I'm left with 1y, then whatever c is would be what my y is equal to. And then once I know what my y is equal to, I then should be able to solve for my x. Okay? If it was a 3 by 3, then it would be a 1, 1, and a 1 on that diagonal with 2 zeros below it. All right, so let's just do this. Let's do some solving. I think that's the easiest way to get what's going to happen is to practice it. Is everybody okay? Again, is it important to remember the words row echelon? No, but if it says anywhere, put it into row echelon form, pretty much you're just solving it. Okay, so here's our first system. We've got x minus 3y equals 1, 2x plus y equals negative 5. So we want to write that as an augmented matrix. All right, so I get 1, negative 3, bar 1, 2, 1, negative 5. All right, now like I said, this is very tedious. Students always hate matrices. It takes us forever to get through chapter 4 because it's a lot of work. But it's not hard once you get it. So your first goal will always, always, always be to try to get that lower left-hand corner to turn into a 0. Okay? So right now, it is a 2. If I were to combine, just think about elimination, because that's pretty much what you're doing is the elimination method. If I wanted to multiply row 1 by some number so that I could add it to row 2 and make it become a 0, what would this have to be? Negative 2, right? What's the opposite of positive 2? Negative 2. Okay, so this is what I'm going to do. I'm going to take negative 2, and I'm going to multiply it by row 1. So our rules say that I can multiply any row by any non-zero real number. So I'm going to put a little arrow to show where I'm going. So now I'm taking all my numbers in row 1 and multiplying them by negative 2. So that gets me negative 2. That gets me positive 6. That gets me negative 2. Row 2 did not change. Okay. Now line 3 in our rules that we wrote says that I can add the product of one row with the new one. So if I do a row 1 plus row 2 and put it into row 2, what would that get me? So row 1 staying the same. So negative 2, 6, negative 2. So do a row 1 plus row 2 and input those new values into row 2. So negative 2 plus 2 is 0. 6 plus 1 is 7. Negative 2 and a negative 5 is negative 7. All right, so now, through all that work, I got a 0 in my lower left-hand corner. Okay. The next thing I want to try to do, after I got my 0 in the left-hand corner, is I want to turn this into a 1. What can I multiply 7 by to make it become a 1?
1/7.
1/7, right? And fractions are going to be your friends here. So now I'm going to do a 1/7 R2, which gets me 0, 1, negative 1 in my second row. Row 1 did not change. Okay, we're almost in row echelon form. I need this to turn into a 1. So what am I going to do to row 1?
Negative 1/2.
Negative 1/2. So negative 1/2, row 1. Gets me positive 1, negative 3, and positive 1. Thank you. I had to think for a second there. 0, 1, negative 1. All right, so for section 4.3, this would be row echelon form. We got our 1s on our diagonals, we got our 0 on our left-hand corner. So, what would your y equal? Because technically this is 0x plus 1y equals, that's a negative 1, it looks like a 7. So y would equal negative 1, right? Now if y equals negative 1, how could we solve for x? Yeah, plug it back in. Well, what would this look like as an equation? Yeah, x minus 3y equals 1. And we just said y equals negative 1. So negative 3 times negative 1 would be a positive 3. Sorry, this is getting really low. I can go up higher for you girls. So x plus 3 equals 1. So x would equal negative 2. Good. Okay. We could have easily just got that by multiplying negative 3 by negative 1, which would have made it become a positive 3. Subtract it over, it gets you to the negative 2. So my ordered pair would be negative 2, comma, what was y, negative 1? Okay. So row echelon form, you're just trying to get that 0. Ultimately, our end game is going to be having only 0s and only 1s over here in our square matrix. But we're not there yet. We're just starting out. All right, so let's try another one. And let's try to condense our steps a little bit. So I'm going to write this one out. So negative 2x plus y equals negative 5. 8x plus 2y equals 2. All right, so let's go ahead and set up our augmented matrix. I've got a negative 2, I've got a 1, bar, negative 5, 8, 2, 2. All right, so now I'm going to try to condense our last 2 matrices that we did, our last 2 steps, into just one step. If you can condense it, then it's less writing on your part, which hopefully makes your life a little bit easier. Okay, lower left-hand corner, that's always where you start. I need this to be a 0. Right now it's an 8. The opposite of a positive 8 is a negative 8. So what do I need to multiply this by to make it become a negative 8? 4. Okay, now watch this. Instead of just multiplying by a 4 as one step and then adding for a second step, I'm going to put it all together as one step. So I'm going to do a 4R1. I'm going to add that to R2. Sorry, my mouse is kind of there in the middle of space. All right, so that's going to get me to a new matrix. Now, because I am taking the product of one line and combining it with the second line, bless you, I'm just going to leave line 1 as it is in my new matrix. So negative 2, 1, negative 5. Because then I want to do that extra division like we did at the end of the last one. So this is where your mental capacity needs to come in. Mentally, I'm going to think times 4 times 4 times 4, add, add, add. If you need to write a little times 4 next to all of those numbers, feel free to do that. Okay, so I'm going to take the product of 4 times row 1. I'm going to add it to R2, which will get me my new R2. So 4 times negative 2 is negative 8, plus 8 is 0. 4 times 1 is 4, plus 2 is 6. 4 times negative 5 is negative 20, plus 2 is negative 18. So we got all of that by doing 4 times row 1, adding it to R2 to get my new R2. So now I've got my 0 in my left-hand corner. My next goal is to turn this into a 1. So what do I need to multiply row 2 by so that turns into a 1? 1/6. Good. So now I'm going to do a 1/6 R2. So row 1 still hasn't changed. Negative 2, 1, bar, 5.
Negative.
Thanks. Negative 5. Row 2 now is going to be 0, 1, negative 3. We're almost in row echelon form. The last thing I need to do is get this to turn into a 1. So negative 2, I need to divide that by negative 2, so negative 1/2 R1. Negative 1/2 R1. Gets a new row 1 of positive 1. Negative 1/2 bar negative 5/2. No, positive 5/2. Sorry. 0, 1, negative 3. All right, so now we're in row echelon form. What's my y coordinate going to be? Y is equal to negative 3. Good. Now we got to solve for x. So my equation is x minus 1/2 times the y, which we said was negative 3, is equal to
Bottom right.
5/2. Yep, because this is your this is 0x. So think about it as 0x plus 1y equals negative 3. Okay. So what's that going to be? Positive 3/2. 5/2 plus 3/2 is 8/2. So 4. Is everybody okay with that mental math? So x is equal to 4. So my answer is going to be 4, negative 3. Okay. Again, ultimately, as we move on in our chapters, we're going to get this to being all 1s and 0s. So then you would just have your x is bam, your y is bam. But that's a lot more work. So we just need to practice this work first. All right, let's finish with a 3x3. So we've got x minus y plus 5z equals negative 6. Three x plus 3y minus z equals 10. X plus 3y plus 2z equals 5. All right, so let's set up our augmented matrix. I've got 1, negative 1, 5, bar, negative 6, 3, 3, negative 1, 10, 1, 3, 2, 5.
So, what's the echelon for this?
Huh?
What's the, how do we solve this one?
So I still need 1s on my diagonal, and then everything below that need to be 0s. So I need these 3 elements to be 0s. Okay? So again, same rule applies. Let's try to get this to be a 0. Well, this is a positive 1. So the opposite of positive 1 is negative 1. So it would be easiest to combine it with line 1 or line 2? Line 1. Just think about your elimination. What would you do over here for eliminating something? You would multiply one of these by a negative and then add them, right? All right, so let's do a negative 1 times your R1, and I'm going to add that to my R3, which will get me a new matrix. So me personally, I need to put the little -1 sign. Time is -1 up there on row 1 to remind me that's what I'm doing. All right, so row 1's not changing. 1, -1, 5, -6. Row 2's not changing. 3, 3, -1, 10. Row 3 is changing. So I'm taking 1 and -1, multiplying, adding. That would get me to 0. -1 times -1 is +1, plus 3 is 4. 5 times -1 is -5, plus 2 is -3. -6 times -1 is 6, plus 5 is 11. Okay, so now let's get another 0. Where do you think we can get another 0 from? Let's try to get this 0 above. How can I turn this 3 into a 0? Multiply row 1 by a -3. So I'm going to do a -3 R1, add it to R2. I'm going to put it up here so those in the back of the room can see. All right, so my new... Huh?
How do you know what to add?
Because I want this row 2, column 1 element to be the 0. So that's why I want to add it to row 2 so that this will go to a 0. Okay. All right, so I'm multiplying everything in row 1 by a -3. So row 1's not changing. The only one that's going to change this move is row 2.
By -1/3 to turn the other 3 into a 1 in advance.
Yeah, usually it's easiest to get your zeros first.
Alright.
Focus on your zeros first. So row 1's staying the same. 5, oops, -6. All right, now row 2's changing. So -3 times 1 is -3, plus 3 is 0. 3 plus 3 is 6. -15 and a -1 is -16. 18 and 10 is 28. Row 3 did not change. 4, -3, 11. Okay. Now where do you think we should go? We need to get one more 0.
The first line by 4.
Now think about this for a second. If I, don't write this, if I do a negative or a +4 R1 plus R3, what would happen to this 0?
It would become 4.
It would become a 4. So now I just threw off that work. So I don't want to use row 1 to get this to a 0. So this is where our fractions are going to become our friends. I need to use a combination between row 2 and row 3 to eliminate that 4. So what do I multiply 6 by
By -2/3.
to get to a 4? -2/3. Okay, and the way that I think about it is if I need a 4 left over, then I need to multiply this by 4/6, right? Because 4/6 would cancel out the 6's and leave me with a 4. If I put whatever that is in the denominator, put whatever this is in the numerator. Well, what is 4/6? 2/3. So I'm going to multiply by a -2/3. All right, so let's do a -2/3, row 2, plus row 3. So that means row 1's not changing. 1, -1, 5. Guys, stay with me. -6. Row 2's not changing. 0, 6, -16, 28. Now row 3, so 0 times -2/3 is 0, plus 0 is 0. 6 times -2/3 would be -4 plus 4, which is 0. 16 times -2/3 is going to be, what? 32 thirds, right? Did I do that math right? 16 doubled, it's 32. 32 thirds. All right, let me do some math over here. 32 thirds minus 3, which is 9 thirds. So 32 minus 9 is 21 thirds, which is,
20.
no, 23, right? 23 thirds? Okay, so we got 23 thirds here. 28, this is where your math frac button will be your best friend, times negative 2 thirds would be, doubling 28 is 56 thirds, so negative 56 thirds plus 11, which is 33 thirds, is negative 23 thirds. Oh, that's nice. Why is that nice? How can I turn this into a 1? Multiply by the reciprocal, which would turn that into a negative 1. All right, so what's my next step? I'm going to do go up here. So I'm going to take row 3 and multiply it by 3 over 23. See, I told you, this is a lot of work. It's tedious stuff, but I see the light at the end of the tunnel. So that goes to 0, 0, 1, negative 1. My third row. Row 2, 0, 6, negative 16, 28. Row 1, 1, negative 1, 5, negative 6. We're almost there. So for it to be in complete row echelon form, this needs to be a 1, this needs to be, or sorry, this needs to be a 1, it is, this needs to be a 1. So what do I need to do to row 2 yet?
Multiply by 1/6.
Good. So 1 over 6 R2 gets me 1, negative 1, 5. Negative 6 for row 1 still stays. Row 2 now becomes 0, 1, 16 over, bless you, 16 over 6 would be, bless you, negative 8 thirds. 28 divided by 6 would be, what, 14 thirds? And then we got 0, 0, 1, negative 1. So z would be equal to what? Negative 1. How would you solve for your x, your y, and your x yet? Turn this into an equation. Guys, stay with me. So we have 0x, we've got 1y minus 8 thirds z is equal to 14 thirds. So negative 8 thirds times a negative 1 is a positive 8 thirds. What's 14 thirds minus 8 thirds? 6 thirds, which is 2. Sweet. Now let's go back up to our first equation, where I have 1x minus y plus 5z equals negative 6. So negative 2 minus 5 is negative 7 equals negative 6. So x equals 1. There it is. Sorry, that was really fast and messy there. 1, 2, negative 1. Okay? Row echelon form. Diagonals are 1s. These are 0s. Try to get your 0s first is the goal.